A gravitational field has a strength of 1.1 times 10 to the minus newtons per kilogram to the right. Okay, how is this possible? I must draw a picture. Okay, here's some spherical mass or something like that, right? And we are here, and that field is this way toward that thing, right? Okay, if I move a mass to the left, what is the change in potential? Well, do you see that if we move a mass to the left, if we're moving it to the left, we're going to increase its potential because we're going to lift it basically up is to the left, yeah? Because here's the mass. Down is toward the mass, up is away from the mass. Okay, so let's figure this out. So what formula am I using? Oh, I know, I'm using this guy. Gravitational field is the opposite of the change in gravitational potential over change in R, right? Okay, so let's use a convention that to the right is positive, to the left is negative. Okay, so 1.1 times 10 to the negative 7th newtons per kilogram is to the right, so that's positive, equals the opposite of the change in potential over the distance. Okay, let's see, hold on. We are moving it to the left, so that displacement is 2.3 negative. All right, so here we go. Let's do this. Let's do our math. 1.1 times 10 to the minus 7th times 2.3 is 2.53 times 10 to the minus 7th, and then that is equal to, that's negative that. So that is our, these minus signs go away, right? So I get that my change in gravitational potential is 2.53, and that is, of course, Newton meters per kilogram, right, or joules per kilogram. All right, what force does this exert on a 1 gram object? Well, let's see, G is F over M. So 1.1 times 10 to the minus 7th newtons per kilogram equals force divided by 1 gram is 0.001 kilograms. I don't need to do that, do I? Oh, that answer is wrong. Interesting. All right, good enough. Okay, so 1.1 times 10 to the minus 7th times 0.001 is 1.1 times 10 to the minus 10th newtons. There we go, of force. Here, the only problem with this was that I used, oh, interesting. Oh, yeah. I mean, the units here are wrong, too. I used this as if it was a gravitational field, but it's not. It's a potential. All right. I think we got the right answer. All right. Wow, that was a train wreck.